Okay, so today will be the last lecture of the chapter. And on Tuesday, you have to report 720 to the lower gym with your number two pencils. No calculator. Because they're going to start the test promptly at 7:30. So if you show up at 7:30, you're probably going to get yelled at. Okay, period 4. Number 6 is the only one. Very good. Oh, so you don't have any questions? Okay, number 6. Does everybody understand that problem? To find the area of the triangle, you just put the coordinates into that determinant, and the absolute value of that, of 1/2 the determinant is the area. And you know why you have to take the absolute value? Yeah, because sometimes if the determinant comes out negative, and you can't have negative area. It's quite easy. There are many applications of determinants, that's just one of them. Okay, then we just move on then. Okay, so today, so of course, when you guys did number 5, did you guys come down the first column? Or you took the challenge and went across the first row? Okay, now we're going to find out, we're going to learn some theorems about determinants. And then we're going to learn Cramer's rule. Okay, now look at your notes. Your notes should have all the theorems on it. The notes, your 11th grade should be on your iPad. Now why did a rat chew a hole in your homework? Whatever animal. Okay, who has the notes on? Okay, what's the first one say? Is that the first one? If one row is a multiple of another row, or one column is a multiple of another column, the determinant is 0. Is that the first one? Right? Okay, so for example, and all the theorems that we're learning now works with just not rows but columns now, right? So if one row is a multiple of another row, or one column is a multiple of another column, the value of the determinant is 0. So example, 1, 2, 3, 7, 9, 2, 3, 6. So if you have to compute the value of this determinant, you don't even have to do any work. You just look at it and go 0. How come? Because the first column and the third column are multiples. Isn't this just a multiple of 3 of this one? If one column is a multiple of another column, automatic 0 already. Of course, you can go ahead and compute it, but it's going to come out 0. But of course, isn't it hard to kind of tell when all the numbers are in there? It's hard to tell one, but this is a theorem though, so it may come in handy. Okay, what's the next theorem? No, that's not it. Okay, let me look over here. Where are the theorems? There we go. Properties of determinants. Okay, if one row is multiplied by a non-zero, oh, I stopped listing this one. Non-zero constant. Oh, okay. So if you, okay, so here. Okay, are you guys reading that property? If you multiply any row by a non-zero number, then the value of the determinant gets multiplied by that number. And the same thing with a column. You multiply any column by a non-zero number, the value of the determinant gets multiplied by that number. Like this here. Like 2, 3, 4, 5. What is this equal to? 10 minus 12. -2. See, if you ever forget your properties, just do it on a 2 by 2 and then you can kind of refresh your brain. Okay, pick any row or any column. Okay, second column, let's multiply it by 3, say, okay? I'm going to multiply the second column by 3, and you get 12 and 15. What's the value of the determinant now? 30 minus 36 is -6. What happened? multiply any row or column by a number, it gets multiplied by that number. So here, I like to give this problem. A, B, C, D, E, F. This was on a quiz a couple years ago. This is equal to K. Therefore, what is this equal to? 2A, 2B, 2C, 2D, 2E, 2F, 2G, 2H, 2I. What is this equal to? Now, the people who don't study their properties, they go, oh, 2K. Wrong. It's 8K. Because if you multiply this row by 2, the whole thing gets multiplied by 2. And then you multiply this row by 2, gets multiplied by another 2. Then you multiply this row by 2, it gets multiplied by another 2, so that's why it gets multiplied by 8. Anytime you multiply a row by a number, you multiply the determinant by the number. You get it? Huh? That was math team? They copied you. Okay, next one. If two rows are interchanged, the value of the determinant gets multiplied by -1. So, if you switch any two rows or any two columns, the value of the determinant gets negated. So here, look at this one. This is -2. So, what if I switch, you want to switch the two columns or the two rows? It doesn't matter. Okay, let's switch the two columns like this. So, whoo, you get 3, 5, 2, 4. What's the value? 12 minus 10 is 2. Oh, 2. See how the thing got negated? So if you switch any two rows or any two columns, it negates the value of the determinant. Okay, now here's the most important one. Look at D. If a row is multiplied by a non-zero constant and then is added to another row, the value of the determinant doesn't change. Okay, so let's take this one right here. And you can also do this with columns as well. Okay, so pick one of these rows. It doesn't matter, one or two. Okay, leave the second row alone. I'm going to multiply this by some non-zero number and add it to that. Okay, what non-zero number you want to use? Okay, 5. Multiply this by 5, add it to that. Multiply that by 5, add it to that. 22. Pick 5. Multiply this by 5 and add it to that. 28. Okay, now compute the determinant. This times this is 110, minus that times that, 112, you get -2. See, it's the same, it didn't change. So if you multiply a row by a number, add it to another row, it doesn't change the value. And you can do that with the column as well. Oh, so how can we use that, Mr. Ba? Well, this is going to come in very handy because on the test, you're going to have to compute multiple, I don't know how many, lots of 4x4 determinants. Okay, 1, 2, 3, 4. 2, 4, 1, 2. 3, 1, 2, 1. 1, 3, 2, 2. Try to keep the numbers down. Because you know when you put bigger numbers in. Mr. Burke, like last night's homework at least had 2 zeros. This one don't have any zeros. That's right. So what we can do is we can use that fourth property to generate zeros. Now watch. Now if you don't generate zeros, you're only going to have heartache on this test. You want to generate zeros. So first thing you do is you look for a 1 first of all. Okay, I see plenty ones here. And don't worry, I'm going to give you a 1 on the test. So which one do you want to use? You want to use this one? You want to use it in the row or the column? It doesn't matter. Wrong. No, it doesn't matter. Okay, you want to do column? We'll do column. Most people pick. Okay, so you keep this column. You don't touch it now. It has the 1. Now our goal is we want to generate 3 zeros in a row right there. Because if you can get zeros all in a row or a column, then that's the row or column you picked, right? Okay, so our goal is to get zeros. Okay, so we're going to keep this column. What do I need to multiply this by? When I add it to that to get 0. -2. And that's the fourth property, right? If you multiply a column by a number and add it to another column, it doesn't change the value. So multiply by -2 and add it to that. 0. Multiply by, but you got to do it to the whole column. You can't just do it to one element. Huh? Multiply by -2, add. Oh, that's a bonus 0. -2, add. -2, add. 1. That does not change the value of the determinant. Okay, but see, 1, 0 is not enough. We want to get zeros here and here. So if I want a 0 here, what do I have to do? What do I have to multiply this by? So when I add it to that, you get 0. -3, but you got to do it to the whole column. Multiply by -3 and add. 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 That doesn't change the value. And lastly, we want to get a 0 right there. So what do I have to multiply this by? So when you add it to that, you get 0. -4. So multiply this whole column by -4 and add it to this one. So multiply by -4 and add. Multiply by -4 and add. -4 add. -4 add. Both of these determinants have exactly the same value. Which determinant would you rather compute? That one, because it's got 3 zeros in a row, that's why. Remember last night's homework? It had the 2 zeros, so you picked that one. Oh boy. Now do you see why you look for a 1? Because if you don't use the 1, then you gotta, okay, let's say you use the 3. What do I have to multiply that by so when I add it to that you get 0? -2/3. You really want to work with fractions? Some of you can barely work with integers. So that's why you look for the 1. Now, of course, what happens if there's no 1s in there? Then you gotta work with fractions then, yeah? But like I said, I'm gonna give you a 1. It's up to you if you wanna use it. You'll have at least one in there. Okay, now, after doing all that work, if you don't go across the first row, you're dumb. That's dumb, that's just dumb. I mean, if you can come down the second column, but only get 2 zeros, this will get 3 zeros. So the answer, and don't forget the plus minus thing, yeah? So it's gonna be plus 1 times, what do you get when you cross out the row and column that it's in? 0, -5, -6, -5, -7, -11, 1, -1, -2. And the rest we don't care because it's going to be -0 times something, plus 0 times something, -0 times something. We don't care, we don't care, we don't care because it's 0. That's why you pick the one with the zeros. So instead of computing 4 3x3 determinants, you just got to compute 1. Isn't that a lot better? And this is how you're going to do it on the test. Okay, now, I got it down to a 3x3. What do you want to do? You want to generate more zeros or just compute the darn thing already? Now, if I were me, I'd just compute the darn thing already. Okay, here, let's do that. So, and don't forget this 1 now. Students, they forget that. But multiplying by 1. Okay, let's go across the first row. It's going to be, what am I even doing that for? So, forget the 1. The 1. Okay, so it's going to be 0. Don't forget, it's plus minus plus now. So 0 times something, plus 5 times something, minus 6 times something. Because it's minus, right? Minus -5 is plus 5. So we don't care about this one. What about this one here? Cross out the row and column that it's in. So you get 10 minus -11. 21. Okay, what about that one? Cross out the row and column. So you're going to have 5 minus -7. 12. So you're going to have 105 minus 72, and that's going to be 33. That's the determinant. Or, like I said, if you want to generate more zeros, you can. So, if you're in the mood to do this, so you already got a bonus 0 over here. So, think about this. Why not use this 1 to make that a 0? So what do I have to multiply this by? So when you add it to that, you get 0. 5, but you got to do it to the whole row now. Multiply by 5 and add. Multiply by 5, add. Multiply by 5, add. So after doing all that work, you better come down this column, right? Because you got the zeros. And is this 1 in the positive or the negative position? Positive. It's positive, plus minus plus, right? So it's going to be positive 1 times, cross it out. So you get this times this, which is 105, minus that times that, which is 72. And you still get 33. Because you're not going to get to use your calculator. You cannot just punch it in and go determinant of this. You're going to do it on your own. So tonight, you guys got to practice computing 4x4 determinants quickly with those zeros. So you've got to generate zeros. It's not that hard, just take practice. Okay, and then the last thing we got to learn today is Cramer's rule, which you guys learned last year, yeah? Cramer's rule. Now on the test, I'm going to tell you right now, number 1 on the test is you're going to have to use Cramer's rule. I'm going to give you 4 equations and 4 variables. Now I'm going to show you how Cramer's rule works with 3 equations, 3 variables. You guys at Mr. Takieso did 2 equations, 2 variables last year, right? Mr. Rubash students, you guys told me 3 by 3. Now, in pre-calculus, we do 4 equations, 4 variables. Okay, so first I start out with the answer. I make the answer nice. Okay, so here we go. W plus X plus Y plus Z equal 10. W minus X plus 2Y minus Z equals 4. 2W plus X, no! Minus X minus Y plus Z equals 8, 5, 3, 4. And then finally, 3W minus 2X minus Y minus Z equal, well, 3. Okay, there you go. Get rid of the evidence. Here, 4 equations, 4 variables. Use Cramer's rule to I thought we were doing 3 equations, 3 variables. Who changed it to 4? That's okay, since I did it, we'll do 4. Okay, so if you guys remember Cramer's rule from last year, first you gotta compute D. D is the determinant. 1, 1, 1, 1. 1, negative 1, 2, negative 1. 2, negative 1, negative 1, 1. 3, negative 2, negative 1, negative 1. Where did these numbers come from? Those are the coefficients. And when you do Cramer's rule, it's probably good to think, okay, this is the first, the W column, the X column, the Y column, the Z column. You guys remember Cramer's rule, right, from last year? Okay, so typical period 3 response. Okay, now we gotta compute D sub X. Does anybody remember? You take the constants and you put it in the X column, like that. Everything else stays the same as the original one. So 1, negative 1, negative 1, negative 2, 1, 2, negative. Now is it starting to make sense? What? That's what I said, the W column. That's why they call it D sub W. Guys, go period 3. So D sub X now, you take the constants and you put them in the X column. So 10, 4, 4, 3. Everything else stays the same as the original. See, the original determinant is the key one right there. 1, 1, 2, 3. 1, 2, negative 1, negative 1. 1, negative 1, 1, negative 1. So what do you think D sub Y is? You take the constants and you put them in the Y column, which is here. 10, 4, 4, 3. Everything else stays the same as the original. 1, 1, 2, 3. 1, negative 1, negative 1, negative 2. 1, negative 1, 1, negative 1. And finally, D sub Z. What do you think that one is? You take the constants and you put them in the Z column. 10, 4, 4, 3. Everything stays the same as the original. 1, 1, 2, 3. 1, negative 1, negative 1, negative 2. 1, 2, negative 1, negative 1. Now, once you compute all of these determinants, then we can get the solution. So therefore, X is equal to D sub X over D. No, we start with W again. X is equal to D sub X over D. Y equals D sub Y over D. And Z is equal to D sub Z over D. Does that sound familiar from last year? It should, because Cramer's rule, right? I'm telling you right now, this is number 1 on the test. Okay, so what do you have to do for number 1 on the test? Yeah, I know Cramer's rule, I just said that. But what do you have to do? You have to compute 5 4x4 determinants. So if you cannot generate zeros quickly and compute this quickly, what's going to happen? Pain. That's what's going to happen. It's going to be crying. Because I thought this was supposed to be easy. It is if you practice your 4x4 determinant. So tonight's homework, did I give you 4x4 equations for variables? Why do I even ask questions in period 3? I should just ask myself and answer the question. Anyway, when you solve two equations, two variables, what does that mean? What are you finding, actually? When you solve two, that's an actual question, people. When somebody asks you a question, it's polite to answer. When you solve two equations, two variables, what are you actually finding? Where two lines intersect, right? When you solve three equations, three variables, what are you finding? Where three planes intersect. What about four equations, four variables? Where four hyperplanes intersect. And so forth, and so forth. Now, let me ask you this. I erased it, but d sub w, w is equal to d sub w over d and so forth. What would happen if d comes out to 0? What happens when you compute the determinant d and that comes out to 0? How are you going to divide by 0? What does that mean? Okay, Chai said they don't intersect. What doesn't intersect? Yeah, but what if it's planes and hyperplanes? What happens when this is 0? You know, I gave this as a bonus question several years ago. What would happen when using Cramer's rule when d comes out to 0? What does that mean about the system? Oh boy. What would you put down as an answer? Again, why am I asking? What would happen if this is 0? What does that mean about the system? Either the system is, what's the words I'm looking for that we learned in Algebra 1? The system is either inconsistent or, you said it, Chai, dependent. What does it? It's in your Algebra 1 book. Mr. Teskey showed it to me. I just made that up, but I'm sure it was in the book. Every Algebra 1 book. Okay, okay, let's just do lines then, okay? Two equations, two variables. It's either one of these possibilities. If the system is consistent, that means the two lines intersect at a single point. That's what consistent is. What do you think inconsistent is? The two lines are parallel, which means there's no solution. And what do you think dependent is? The two lines are the same line, which means you have an infinite number of solutions. You guys learned that, right? I think you have to have these three pictures in your Algebra 1 book. So, when using Cramer's rule, when d comes out to 0, what does that mean? The system is either inconsistent or dependent. That's what it means. That means they intersect at no points or an infinite number of points. We like it better when it's consistent because we just get a nice clean answer. But you know, in real life, lots of times that's not true. It doesn't come out consistent. So you have to be able to deal with these other ones. Okay, we are done. That's the last of the lecture. So now, what you have to do is you have to hone your skills. Oh yeah. I was going to teach you how to do something, but actually when you do one of the problems of tonight's, okay, one of the problems on the test, okay, well this is number 1, okay. Another problem on the test is I'm going to give you a 3x3 matrix, okay, a matrix now, not a determinant. Make up numbers, 2, 3, 5, 1, 2, 3, 4, 2, 1. Let's make up something. Compute the inverse of that. Now we already did this, right, on matrix 2, right? How did we find the inverse of this? A, B, C, D, E, F, G, H, I. But that's kind of a long thing. Yeah. Is there a better way? Well, there is a shorter way, but you gotta know something. One of the problems of tonight's homework is gonna take you by the hand and lead you through the procedure for finding the inverse. And that's problem number 3. You want me to just teach it to you now? Yes. Okay, I will. Okay, how do you, yeah, we have time, plus it's on the video. The other class is suffer. Okay, find A inverse. Do I want to use, now this method I'm going to show you doesn't only work for 3x3 now, it works for A. In fact, it even works for the 2x2, but you guys, okay, now watch what I'm going to do. First step, if you follow the thing on the homework, replace each element with its cofactor. What's a cofactor again? That's the minor multiplied by either the 1 or the -1. So which is the ones you multiply by -1? The ones in the negative positions. Which ones are in the negative positions? Right here, right? So this is what I do. See how I put the negative sign on already? Okay, now I'm going to replace each element with its cofactor. So this element, if I cross out the row and column that it's in, what's left? 2 minus 6. You replace it with -4. You replace each element with the cofactor. What about the one up here? Cross out the row and column. 1 minus 12. But see, then you got the negative there. You don't have to worry, it's there. What about that one? Cross out the row and column. 2 minus 8. And if you keep on going, 3 minus 10, -7. That one in the middle, 2 minus 20. That's ugly, -18. This one here, cross out the row and column. 4 minus 12. People, if you cannot handle single digit numbers, 12 is not single digit. Okay, then cross out these. 9 minus 10. What? Cross out these. 6 minus 5. And then finally this one, cross out. 4 minus 3, 1. Okay, so all I did is replace each element with its cofactor. Next step, if you read on the list, transpose this matrix. Now, did we learn how to transpose a matrix yesterday? You bet your sweet pippy we did. That means you switch the row and column number. So the first row now becomes the first column. So -4, 11, -6. 7, -18, 8. -1, -1, 1. You transpose it. In other words, reflect it over the main diagonal. Were you guys here yesterday? This is you got the period 3 stare. You got to face the camera. No, your face is not even like that. And then finally, the last step. You multiply this matrix by 1 over the determinant of the original matrix. How should I go about, you remember how to compute a determinant? You multiply, pick any row or any column, this is last night's homework, and then you multiply each one by its cofactor. But you know what? These are the cofactors right here. You got the cofactors there. So you just got to go 2 times that, this times this, -8, that times that, 33, and then that times that, -30. What is that? -5. There you go. This is the inverse. This is another technique, and this technique works for any degree square matrix now. Even 2 by 2. Look. Someone will be going, what are you talking about, Mr. Park? Okay, look. 2, 3, 5, 7, whatever. Okay? How do you find it? Now we have the theorem, but we don't even need the theorem anymore. We just use this method. Replace each element by its cofactor. So this one here, cross out the row and, okay, wait, these are the negative positions here. Cross out the row and the column. What's left? 7. What's that? Wait, no, there. 5. Cross out the row and column. 3. Cross out the row and column. 2. Transpose it. So first row becomes the first column. Second row becomes the second column. Now multiply by 1 over the determinant of that, which is 14 minus 15, which is -1. That's the inverse. Is that the same thing as the theorem we learned a couple days ago? Remember, you go 1 over this times this minus that times that, and then you switch these two and negate those two, and it's the same thing. Yeah, but that's just an extension of what I taught you right here. Okay, I taught you everything. There's nothing left to the imagination already. Okay, got 3 minutes left. I'm not going to teach this to the other classes because they can watch the video. Anyway, it's leading you by the hand in that problem. It's telling you what to do.